099?
Yes, and you know this is the only course with this expertise across the world.
No way.
Yes way. Don't delay. Enroll now.
Geeks learning together.
Okay, so hi everyone. Let me check that whether I'm audible or not. Just wait for a second. Okay, so hello everyone. Myself, Ayush Tripathi, our DSM mentor and problem setter at Geeks for Geeks, and I welcome you all to this post analysis of the last problem of the day, which was named as camel case pattern matching. So let me first share my screen. Okay, so hello everyone. Myself, Ayush Tripathi. Okay, can someone please confirm that my screen is visible or not? Hello. Hi, hi. Okay. Okay, sorry guys. I really sorry for that. There was some network issue from my side. Now it's fine. Okay. So I guess you guys are ready to move forward. Do write a +1 in a chat if you guys are ready to move forward. Then we start. Yeah, fine now. Okay, thanks, Rishit. +1. Okay, so let's get started. So the problem name was, let me share my screen first. Yes. So the problem name was camel case pattern matching. So basically, in this problem, we have been given a list of words, or we can say dictionary, where each word follows the camel case notation. And here the camel case notation means that the first letter of the word is in the capital and all rest of the letters is in the small. And we also have the string pattern, and our task is to find the strings that matches with the given string pattern. And how do we check that whether the string matches with the pattern or not? So we only check the capital letters, that whether the capital letters are matches with the pattern, and this pattern string consisting of the uppercase characters only. So let's take this example, and here I am only taking the single word, this one. So now let's just move to the board. So here we have the word welcome to Geeks for Geeks, and our pattern is WTG. So if I extract the capital letter from this word, then what we get? We get W. This was the first capital letter, then T, then again G, then F, then G, then F, then again G. So we get W, T, G, F, and G. And our pattern is W, T, G. So this word is matches with our pattern. We only need to check for the prefix. We do not allow to check for the any substring rather than this prefix. So we simply include this word in our answer. Alright. So is the problem statement clear to everyone? Please write a plus one in a chat. So now let's take this example, geeks for geeks, and let's see whether this string is matches with our pattern or not. So the next word that we have is geeks for geeks. Geeks for geeks. Alright. So if I extract the capital letter from this word, then what we get? We get G, F, and G. We get G, F, and G. But our pattern is W, T, G. So this string word does not matches with our pattern. So we simply discard this word. Alright. Or let's take one more example. This welcome geek. So the next word that we have is welcome geek. So if again I extract the capital letter from here, then what we get? We get W and G, because these were the only capital letters in the given string word, and our pattern is WTG. So this string word does not matches with our pattern. So we also discard this word. So the only word that matches with our pattern is this welcome to geeks for geeks. So we simply return only this word. Now let's check an output. So in the given output, we only have a single word which is welcome to geeks for geeks. So hope the problem statement is clear to everyone. And also if we do not find any such word, then in that case we have to return -1 in the form of a string in the vector of a string which is denoting our answer. All right. So now let's just move to the solution. So what are the useful informations we required? Can anyone want to share any approach, and then we will elaborate their approaches? Try. Yes, we can solve the problem using try, but I guess the try was not an efficient solution. Even you can easily solve this problem using some greedy observations. Anyone else here? Okay, for every word, find the string found by combination of the capital letters of the string. Okay, if else, yes, they just make sense. If else, okay, I didn't get your approach, Rishit. Okay, so let me share my approach first. So the very first observation, and it's obviously very greedy observation, that the only useful information is the capital letter in the given word of the dictionary, and the order of the capital letter. So if I somehow get the capital letter in the order as they appear in the word, and then I just compare that string with the pattern, and if that matches with our pattern, then I simply add the word in my answer. Is this approach is clear to everyone? That what I have just said. If else, okay. So let me again summarize this. Yes, okay. So what we will do, we simply extract the capital letters. The approach I am referring is to same as yours. Okay, Rishit. Okay. So what we will do, we extract all the capital letters in the same order as they appear in the word of the dictionary. And if they matches with our pattern, then I simply include that word in my answer. So using this key idea, what we will do, we simply iterate over each word. Or let me, okay. So using this key idea, I simply iterate over each word, that is for each category. Then for every word, I iterate all of is the video. Okay, is everything is clear to you, Rishit? Which I can't handle. Sorry for that. But I guess now it's fine. Maybe network issue. Okay. Yeah, it's back now. Okay, so sorry for that, guys. Okay, so what I have just said, that I extract all the capital letters for every word in the dictionary, and then we simply check that whether the extracted capital words matches with our pattern or not. And if they matches with our pattern, then I just simply include that word in my answer. Alright, so using this key idea, we simply iterate for each word in dictionary. Or let me remove this one. Then for each word, we simply iterate over its character. But before that, we have to declare some temporary string in which we are going to store the capital letters. Alright. So let's say we named that temporary string as current. So I simply declare the temporary string, that is string current, and initialize this with the empty string. Alright. And then I just iterate over all the characters of the word, that is for each ch, and here ch is simply denoting the current character in the word for each ch in word. And the first thing that we need to check that whether the ch is a capital letter or not. So for that we simply write a if statement, that is if ch is greater than or equal to capital A and ch is less than or equal to capital Z. So this means the ch is capital letter. So I simply include the ch in my current string, that is current plus equal to ch, and then and after each character we check that whether the current string matches with our pattern or not, because we only need to check for the we also allowed to include the word if the prefix of the word matches with our pattern. So what I mean by this, so if you carefully observe this first example, then here we have the string current as W T G F G, and our pattern is equal to WTG only. So the pattern matches with the prefix of the current, and then also we are allowed to include the word. So after every insertion of the capital letter in the current string, we need to check that whether it matches with our pattern or not. So I just simply check that if current is equal to pattern, nothing is display on screen. Okay, it's blank. Okay, so I'm not getting your issue. Is this thing happening to everyone, that nothing is displayed on your screen? Can someone please confirm this thing? It's displaying now. GFG code window is visible now. Okay, yes. Okay, thanks, Anshit. So let me explain you again. So let me just quickly explain you again. So can you share your OneNote display again? Okay. Is the OneNote display is visible to you, Rishit? Okay, so I guess this is now visible to you. So what I'm doing, I just iterate over each word in the dictionary and declare the temporary string current, and then I iterate over each character of the word, and then check that if the character is capital letter, and if it is capital letter, then I simply include the character in my current string. And every time we need to check the current string, whether the current string matches with our pattern or not, because if the prefix of the current string matches with our pattern, then also we can include the word in our answer. So that's why checking here, if the current is equal to pattern, then I simply include the word in my answer, that is answer dot pushback, and here answer is nothing but the vector vector of string vector of string. All right, so I simply add the word in my answer dot pushback word, and then I simply break the loop, break this loop, this one, because we are not allowed to include the string multiple times. So is the approach clear to everyone? Please write +1 in the chat, then we move to the implementation. Okay, +1. Okay, thanks. Okay, so now let's just see how we implement this solution. All right, so let's just quickly code this up. So the very first thing, I declare vector of string in which I'm going to store the answers and name that string as answer. And then I iterate over each word of the dictionary. All right. So iterate over each word of the dictionary. So for word, and why I am using and here, because if you do not use and, then the given string of the dictionary, then this for loop will create the copy of the given string of dictionary, and that was kind of inefficient and inefficient both in terms of memory and in terms of time. So instead of creating the copy, I am simply referring to the that string only. All right. So here now we are not creating the copy. Is this thing clear to everyone? That why I'm using and only one node is visible. Okay. Okay. I'm not getting your. Okay. Let me reconnect this. Okay. So is now screen visible to you? Can someone please confirm that whether the screen is visible or not? Yes, thanks, Rishit. I'm not getting that what's happening here. Maybe there is some network issue. So I really sorry for that. Anyway, so what I have just said that here I am taking the reference of the here I am taking the reference of the string from dictionary. And if you do not write this and here, then what it just do, this for loop create the copy of the string from the dictionary, and that was kind of inefficient both in terms of memory and in terms of space. So instead of copying the string, I am using and here to take the reference, and then I just copy this here. So simply iterate over all the words of the dictionary, then here declare the temporary string current and initialize this with the empty string. All right, and then I simply iterate over all the characters of the current word, that is auto ch in word, and then simply check that whether the current character is capital letter or not, that is if ch is greater than or equal to capital A and ch. You can also write this and as and operator in this way, but I generally prefer to write in this way. This makes more sense to me. And then if the current character is the capital letter, then I simply include the character in current string. All right. So current dot pushback ch, that is I have added the character in the current string, and then I simply check if current is equal to pattern, then I simply include the word in my answer and break the loop, break this loop, because we are not allowed to include the word again and again. So if current is equal to pattern, then that means we found an happy word that matches with our pattern. So I simply add the word in my answer vector, that is answer dot pushback word, and then I simply break. And after this after this for loop, or we can say after processing all the words of the dictionary, I simply return answer. All right, makes sense? Please write +1 in the chat if Up till here, everything is clear to you. Okay, clear. Thanks, Rishit. Okay, plus one. Thanks, thanks. Okay, so but before returning the statement, we have to check one more condition, and this one, where it is, yes, here. So we have to check if none of the string from the dictionary is matches with our pattern. In that case, we have to return -1. So I simply check if answer dot size is equal to 0. In that case, what I will what we will do, we simply push the -1 string in our answer, that is answer dot pushback -1 in the form of a string, and then we just return the answer. So now let's just try to submit this. Okay, accepted. Can anyone please confirm the time complexity of this solution? That what would be the time complexity? And then we optimize this solution, and then that solution would be the best optimized solution for this problem according to me. Can anyone please tell me the time complexity for this solution? That is, what is the time complexity? O of n into s. Okay, Rishit, makes sense. Where n is the number of words. Okay. Anyone else here? Okay. S is the length of each word, or we can more precisely we can say the length of the longest word. Okay, anyone else? But this time complexity is not up to that mark. You are not precisely correct, Rishit. Anyone else here who want to guess the time complexity for this solution? Okay, so let me just discuss the time complexity. So what about the comparison? Here we are comparing the current string with the pattern. So what about the time complexity for this? Oh wait, I missed the comparison pattern. Yes, Rishit. So to compare two strings, so to compare two strings, let me write S1, the length of S1 and length of S2. So to compare two string, S1 is equal to S2. The time complexity, the time complexity is minimum of length of S1, comma length of S2. All right. Yes, Rishit. Now it's absolutely correct. All right. So this is the time complexity. So can anyone tell me that can we further optimize this complexity? Can we further reduce this time complexity? And if we can, then how? Or just write a -1 if you do not have any idea that how we can reduce the time complexity, so that I got an idea and then move forward. Okay, so let's see how we reduce the time complexity. So currently what we are doing, when we encounter the new capital letter, we match all the previous capital letters that we have encountered so far with our pattern string, and that was inefficient. So what I mean by this, so okay, let's discuss this example, this one only. All right, or let me just erase this thing. So our current, so our word is equal to welcome, welcome to geeks for geeks, right? And our pattern is equal to WTG. All right. So currently, what we are doing when we encountered the new capital letter, then again we match all the previous capital letters that we encountered so far with our pattern string. So we initialize our current string with empty string. All right. So when I add the first capital letter, which is W, then we match the pattern with the current string. That is pattern current is equal to pattern or not. Then we compare these two strings, and when we add T, then again we comparing these two strings, and when I add G, then again I compare these two strings, and so on. But this was kind of inefficient. And why this was inefficient? Because we know that if some prefix of the current string, that is W, T, G, F, G, if some prefix of the current strings matches with our pattern, then the indexing of the characters are same. That is, the characters occur at the same index. So let me write a pattern here, WTG. So if this pattern is matches with the some prefix of current string, then all the characters occurs at the same index. That is, this W occurs at the zeroth index. Alright. This T occurs at the index 1. This G occur at the index 2. So why not to use these indexing instead of comparing every time current and pattern? Is this thing clear to everyone? Please write a +1 in a chat or -1. Can anyone please confirm that whether this thing is clear to you or not? Okay, +1. Thanks, Rishit. What about the others? Is this observation is clear to you that we don't need to compare every time current and pattern? Okay, not getting any response from the others. So we are moving to the implementation. Then now let's see how we implement this solution. All right. So before that, let me share this code with you. Uh, okay, don't worry. Okay, don't recompare parts. Okay, let's see what you have just written. Okay, don't. Yes, Rishit, that what I was saying. That don't recompare the part of the current, and even you don't need to compare any previous capital letters, because then only you move to the next capital letter. So let me explain you again. So now what I will do, I simply iterate over all the characters of the word, and when I encounter the capital letter, then I check that whether this capital letter matches with our character in the pattern or not. And for that we have to keep track of the index. So let me slightly modify this pseudocode. So right now here we are only declaring the string current, but actually we don't need this because this causes the overhead for the comparison. So instead of this string, I keep track of the indices. So here we simply declare a integer variable, or let me write the pattern index, or let's just write index only, index, and initialize this with 0. Okay, is my screen visible to you? Because there is some power supply issue. Okay, visible. Okay, thanks Rishit for confirmation. So previously, what we have declared, we declared the string current, which causes the overhead. So now, and we actually don't need to compare the string. So instead of the string, here I have declared the integer variable named as index, and this integer variable index is referring to the pattern string. And then every time when I encounter the capital letter in our word, then I simply check that if, so let me clear this. So when I encounter the capital letter, then I simply check that if ch is equal to pattern of index, that whether this character is equal to the character in the pattern, then in that case I simply increment the index. So let's dry run on the previous example, which was WTGFG, and our pattern is equal to WTG, right? So when I encounter the capital letter, and also we initialize our index with 0. So when I encounter the capital letter, I simply check that whether they are equal or not. That is ch is equal to pattern of index or not. And if that is the case, then I simply move to the screen is froze. Okay. Okay, is the screen is visible to you now? Can someone please confirm that whether the screen is visible or not? It's still frozen. Okay, thanks, Rishit. Try not sharing your camera. It might be okay. Let me check. Okay, guys. So I guess the mic was connected with the audio. Okay, working now. Okay, thanks, Vishal. So what we have just discussed so far. So what I have said that instead of using the string, now we are going to use the indexes. So whenever I encounter the capital letter, then I simply check that whether the capital letter is matches with the character in the pattern or not. And if it is matches with the character in the pattern, add that index, and that index is basically stored in the index variable. Then I simply increment the index, otherwise I simply break the loop. So what I mean by this, if ch is equal to pattern of index, in that case I simply increment the index. Else what we will do, we simply break our loop. And why we break our loop? Because the prefix not get matched with the pattern. So let's take this example. So let's say instead of pattern is equal to WTG, pattern is equal to WTA. Alright. So we encountered our first capital letter. So we simply check that whether they are matching or not. So they are matching. So we move our index. So here index is referring to the zeroth position. And then I just move our index. So now index is referring to the character T. So when I encounter the character T in the word, I simply check that whether they are matching or not, and again they are matching. So I simply increment the index again. So now index is pointing at this character A, and then I encountered the capital letter G, and this time G not equal to A. So in that case, I simply break the loop because it does not make sense to compare the other characters. Alright. So is this thing clear to everyone? Please write a +1 in the chat. Okay, thanks, Rishit. So, and we have to check one more condition, right? What about the case when you exhaust all the characters of the pattern? In that case, you do not have any character in the pattern to match. Then what next? So for that, we have to check every time that if the index is equal to pattern dot length. If the index is equal to pattern dot length, in that case, this means we found the word in the dictionary with which matches with our pattern. So we simply include that word in my answer. That is answer dot pushback word, and then I just break the loop because we are not allowed to include the character multiple times. So I simply break the loop. And this was the entire solution, and also this was all about the explanation and observation. Now let's just see how we implement this solution. But before that, let me share this code with you, or let me copy the entire class solution. So okay, not get copied. Okay. Okay, so now we are discussing the most optimized solution here. So now let's just see how we implement the most optimized solution. So previously what we did, we have just stored the information in the string character current, but actually we don't need this. So instead of the string, I'm going to use the indexes. So here I have declared the variable index and initialize this with 0. And this index is referring to the string pattern, characters of a string pattern. So here when I encounter the character, capital letter in the word, I simply check that whether this matches with our character in the pattern or not. So for that, I simply check if ch is equal to pattern of index. In that case, I simply increment the index. Otherwise, I simply break. Now we don't need to check for the other characters because this characters does not matches with the given string pattern. And every time we have to check that whether we have exhausted all the characters or not. So if index is equal to pattern dot length, then in that case I simply include the word in my answer, that is answer dot pushback word, and then I just break because not allowed to include the character multiple times. Now let's just run and compile the code. Okay, so we are getting the expected output. Now let's try to submit this. Okay, accepted. And what would be the time complexity now? Can anyone want to guess the time complexity? Okay, waiting for your response, guys. That what is the time complexity for this solution? Okay, so let's just tell me the time complexity. So the time complexity is O of n, and here n is the number of words in dictionary multiplied by the length of each word. Each word, or let me write s instead of s. Let me write word, length of each word, or more precisely, I can say the length of the maximum word in dictionary, and the space complexity is also same, that is n into length of the maximum length of the word in the dictionary, because in best case all the words from the dictionary get matched with our pattern. So this was the time and space complexity. So is the solution clear to everyone? Please do write the plus one in a chat. Okay, clear. Thanks, Rishit. share the entire solution. All right. So now here sharing the solution. Okay, Rishit, why the time complexity is added to the length of word plus length of comparison, I guess. This was not the time complexity. The time complexity is this one. Okay. So if you guys have any query regarding the problem, then feel free to write this in the comment. And also, if you have learned something new, then please hit the like button. And apart from that, your feedbacks are really important for me. It help me to improve the upcoming session. So do write the feedback in the comment. Yes, Rishit. Okay, so thank you so much for joining the session.